Introduction. A new era of computing. We're entering a new era of computing, and it's happening on two fronts at once. In the past, big shifts moved us from mainframes to PCs, then to the internet, the cloud, and mobile phones. Today, the shift is to AI. But there's a twist. We're not just making AI apps. We're building every kind of app on top of AI. And we're changing how software is created and run. Instead of only writing code, we also train AI. Instead of running mostly on CPUs, we use GPUs. Instead of showing pre-designed screens, AI now generates words, images, and even video on the fly, based on your context. Because of this, the whole computing stack, from chips to data centers to models and applications, is being rebuilt. Why AI investment is surging? Why is there so much money and energy pouring into AI? Because nearly every company and industry sees that modernizing their tools with AI can save time, cut costs, and unlock new products. Venture capital is flowing in, big R&D budgets are shifting to AI, and everyone from startups to global firms wants in. How we reach today's AI capabilities, how we got here, is a story of steady breakthroughs. Around 2015 to 2017, new AI techniques, like transformers, made language understanding much better. In 2022, chat-based AI made the power of these models obvious to millions. In 2023 to 2025, we saw reasoning AIs, models that don't just answer once and stop, but think through steps, use tools, and check facts as they go. We also learned that AI isn't just about text. It can understand and generate images, audio, video, 3D scenes, and even patterns in biology and physics. Two ideas stand out. Physical AI, AI that can understand the real world and act in it, like robots and self-driving cars. AI physics, AI that learns and predicts how the physical world behaves, weather, fluids, motion. The rise and impact of open-source models, open-source AI, has also taken off. Many powerful models are now open, so students, researchers, and companies everywhere can use and improve them. These models might lag top proprietary models by a few months, but their speed of improvement and wide availability mean AI is spreading fast. Nvidia's open, full-stack approach. Nvidia builds the full stack needed for this world and shares most of it openly. That includes massive in-house AI supercomputers to train models, open models across domains, language like Nematron, biology, La Proteina, OpenFold, Evo, world modeling, Cosmos, robotics, Groot, and self-driving, Alpamayo. Open libraries and tools, Nemo families, that help you prepare data, generate synthetic data, train, evaluate, add safety guardrails, and deploy. From models to agents, a new kind of software. These pieces enable a new kind of software, agentic systems. Think of an agent as a smart helper that decides when it needs to look things up, uses the right tools and services for each task, breaks complex jobs into steps and completes them, can coordinate with other specialized AIs. Intelligent routing and customization. You can also route each user request to the model best suited for it. Sensitive tasks can run locally, while others can call a top model in the cloud. This lets you customize your AI with your private data and skills, while still tapping the latest frontier models when needed. Building a personal assistant that manages your calendar, email, to-dos, and even a small home robot is now surprisingly straightforward with these building blocks. Enterprise adoption of agentic interfaces. Enterprises are adopting this fast. Companies like Palantir, ServiceNow, and Snowflake are weaving agents into their platforms so users can interact with systems more naturally through conversation and multimodal input instead of just forms and spreadsheets. Why simulation and synthetic data matter? Now consider the physical world. To give AI common sense about reality, like understanding gravity, friction, or that objects persist even when you look away, it needs experience. But collecting enough real-world data is slow and expensive. The answer is high-quality simulation and synthetic data. Nvidia's Omniverse creates realistic digital twins of the world. Cosmos is a world model that can generate video, predict motion, and simulate cause and effect. Together, they turn computing power into training data, so AIs for cars and robots can learn safely and quickly. Alpamayo, a reasoning-first self-driving AI, this foundation powers Alpamayo, an end-to-end AI for self-driving cars. It takes camera input and decides how to steer, brake, or accelerate. It also explains what it plans to do and why, important for safety and trust. Alpamayo learns from human driving, from carefully labeled examples, and from Cosmos-generated scenarios, including rare edge cases you might never see in normal data collection. For extra safety, it runs alongside a traditional, fully traceable driving system. A safety policy chooses which system is in control at any moment. This redundancy and diversity is a best practice in safety engineering. With partners like Mercedes-Benz, these systems are entering production, and they'll keep improving over time. The same approach scales to many kinds of robots trained in simulation and deployed on efficient edge computers like Nvidia Jetson. Designing chips, systems, and factories in software upstream. The industries that design chips, machines, and factories are also transforming. EDA and industrial software leaders, Cadence, Synopsys, Siemens, are integrating NVIDIA's accelerated computing, Omniverse, and AI models. The goal is to design chips, systems, and even entire factories as virtual twins, test everything digitally, and only then build in the real world. Think of factories themselves as giant robots, designed, simulated, validated, and optimized in software first.